I'm going to introduce the idea of vectors. Now it's important to know that vectors have two parts, a size or magnitude and a direction or orientation. So if we're given a vector u, which we designate with a small arrow over the top, and it has coordinates p, it has the point P at one end and Q at the other end. And the coordinates of P are 1 and 2, 3 and 5 right there. Now, what you're going to do, this is called the component form, and you're going to use the distance formula to figure out the magnitude of the thing. So, what I have over here is the distance formula. Give me a moment. Now, the difference in the x coordinates, which is 3 minus 1, plus the difference of 5 minus 2, squared right there, plus squared, you're going to get 2 squared plus 3 squared. 4 plus 9 is 13, and you've got the square root of the whole thing. So therefore, the magnitude of u is the square root of 13. And I'm going to use the notation, the absolute value of, and then the absolute value or the size or the magnitude of this particular u value is 13, the square root of 13. Now, over here, we're going to learn how to add vectors. Now, you can take a vector v and you can simply move it up to here as long as you maintain the same magnitude and direction. You're going to put them head to tail, and then you're going to add using the parallelogram method. And that consists of making a parallelogram, and let's see, make a parallelogram like so, and then dot dot dot. The magnitude of the sum is the diagonal line, which becomes u plus v. Now, to subtract, we're going to add the opposite. So you're going to have u minus v. In this case, you're going to take u, the same vector, you're going to take the orientation of it, and you're going to invert it, so v comes like this, and then you take the opposite direction, and you're going to get the opposite of v, vector v. And then you add those together by the parallelogram method. And then you'll end up with that vector right there is going to be the sum, and that's going to be written as u minus v. And then, lastly, scalar multiplication. And if you want to double 2u, double it, you're going to go along the same line, and you're going to make a vector that is twice as long as the original one. So u plus u equals 2u.